We have CH3COOH. That's a weak acid. We have Rb and CH3COO. This is a salt. This is going to break apart into Rb plus, and this is going to break into CH3COO minus. Rb plus is a do nothing or neutral cation, so we're left with acetic acid and acetate with a minus on this CH3COO minus. So because the question tells us we have a one-to-one solution, that means we have a buffer in this case because we have a weak acid and its conjugate base. So when we have a one-to-one buffer of a weak acid and its conjugate base, the pKa equals the pH. So the pH is 4.7. So this is going to be an acidic solution. Next, we have NaOCl. This breaks apart into Na plus and OCl minus. Na plus is a do-nothing cation. OCl minus is going to act as a weak base. This breaks apart into K plus and CO3 2 minus. K plus is a do-nothing cation. CO3 2 minus is going to act as a weak base. So this is going to be a basic solution. You have HCN and CSCN. HCN is a weak acid. CS plus is a do-nothing cation. Cn minus is going to act as a weak base. Again, we have a weak acid with its conjugate base, and the question tells us it's a one-to-one solution. So the pH equals the pKa. pKa is 9.3, so the pH is 9.3. We're going to have a basic solution. Here we have NH3. That's a weak base. We have NH4 plus when we break this apart, and we have NO3 minus. NH4 plus is going to act as a weak acid. NO3 minus is a do-nothing anion because it comes from a strong acid. So we're left with a weak base, NH3, and its conjugate acid. Again, it's a one-to-one buffer solution, so we have a buffer here. So the pKa is equal to the pH. The pKa is 9.2, so the pH is 9.2. Here we have HSBF6, and the pKa for that is minus 10 because that's not the pKa for a strong base. That should be obvious. So we have a strong acid with a strong base, neutral solution.